Fabulous. Well, welcome to the internet, protecting our democratic lifeline. I'm Brett Sheffield from the LibreCast project, and we'll be talking a little bit more later about what that project is and what we're trying to achieve. LibreCast is now part of the NLNet NGI Zero program, which is trying to build the next generation internet. If you want to know more about that and perhaps get some funding for your project, come and talk to me afterwards and I'll tell you all about it. I'm basically going to make a simple argument, and that is this, that the internet is the greatest democratic tool we've ever built as a species, that it's under threat from a number of different angles, and that if we don't do something about it, then the consequences for our freedom, our democracy, and our way of life will be quite serious. So cheery stuff. Before we begin, I just wanted to acknowledge the Uganda people and also check my white privilege. I am white, I am male, I have benefited greatly from the atrocities committed in my name, and so let's move on. I should warn you, you probably got it from the title, we are going to be talking a little bit about politics. It's not everyone's favourite subject. Who doesn't like talking about politics? Who's bored by politics? Who likes democracy? Yeah? Okay. Who doesn't like democracy? Come on, there's got to be somebody. Okay. Now, we've got our first problem there. I don't think everyone voted. So, I think that's $50 from anyone who didn't put their hand up then. Now, there's a bit of a problem there. For a democracy to function, I mean, yes, you need to turn up and vote, and that's quite important, obviously. But if you just turn up and vote and you haven't bothered to inform yourself, then you're just contributing randomness and nothing very positive. It's all noise and no signal. So it's important we talk about politics, even if we don't like it. You need to talk to your friends, to your family. You need to inform yourself, discuss the issues of the day. Otherwise, we don't have a democracy anymore. If you don't like talking about it, and your mates don't like talking about it, and your family and your colleagues don't like talking about it, pretty soon we don't have a democracy anymore. So that's that. I like to work here at the intersection of human rights and technology. This is what interests me. For many, many years, I've been writing code since I was about this high. I started out on the Commodore 64 and moved on from there. I've written a lot of code that really doesn't matter in my life. I've written a lot of proprietary code that I can't even see anymore. But over time, I've moved towards open source, free software, and I've started to care more and more about human rights. And I think as technologists, we need to care more about that. There's two sides, two faces to this. The first is how technology can help us preserve and protect our human rights. There are some good projects out there, some good software that can help us. Tor, OpenVPN, Privacy Badger, Monero, don't use Bitcoin, it doesn't protect your privacy. Monero does that. And then the other face of things is the not so good technologies, trying to protect ourselves from the damage that technology can do, the ways in which it can invade our rights. Amazon rings and blanket surveillance and this sort of thing. Artificial intelligence, that's what that's meant to represent. Surveillance capitalism, and, well, drones with guns. I thought we'd just throw that one in there. So what do we mean when I talk about human rights? This is the UN Declaration of Human Rights. That's one of the documents that defines the human rights that we all have.
Always carry one with me.
Excellent. This is good. How many of you read the UN Declaration on Human Rights? Okay, a few of you, that's good. Not many people do. So there are a number of documents that define what our human rights are. There's the UN Charter. There's also the EU Charter of Fundamental Rights. It's a little bit more modern, talks a little bit more about digital issues. Pretty much every country in the world, well, every democracy in the world has a Bill of Rights. No. Every democracy in the world has a Bill of Rights except one. Would you like to hazard a guess at which country, which modern democracy, does not have a Bill of Rights? Well done, yes. There are some state ones. There is a sort of ACT Bill of Rights. There's now a Queensland one as of 2018, which was a bit controversial. Yeah, pretty kind of nice if there was something in at a federal level that restated this in a way that we, so that we have it in our federal laws. So let's take a look at some rights. I'm not going to run through them all, don't worry, but I mean, there's some obvious ones like this. It's nice. Nobody has the right to just arbitrarily kill us. And then there's quite a few more that I think are quite applicable to us in the technology arena. Article 12, nobody shall be subjected to arbitrary interference with their privacy, family, home or correspondence, nor to attacks upon their honour and reputation. So we've got the right to privacy. The EU Charter says it a little bit differently. Everyone has the right to respect for his or her private and family life, home and communications. So that's a little more explicit. Furthermore, they have Article 8. Everyone has the right to the protection of personal data concerning him or her, and such data must be processed fairly for specified purposes and on the basis of consent of the person concerned or some other legitimate basis laid down by law. Everyone has the right of access to data which has been collected concerning him or her and the right to have it rectified. So back to the UN, Article 19, everyone has the right to freedom of opinion and expression through any media and regardless of frontiers. Definitely some technology applicable parts there. Article 20, Section 1, everyone has the right to freedom of peaceful assembly and association. That applies on the internet too. That means you can talk to your mates. That means you can get together on your IRC channel and organise and form a knitting group or form a political group. You have that right. Article 21 is pretty much all about democracy. Section 1, everyone has the right to take part in the government of their country, directly or through freely chosen representatives. Section 2, everyone has the right of equal access to public service in their country. And Section 3, the will of the people shall be the basis of the authority of government. Basically, we can have free and fair elections. So we've definitely got the right to a democracy. And Article 26, right to education. Yes, there are technology applications there. Article 27, everyone has the right to freely participate in the cultural life of their community, to enjoy the arts and to share in scientific advancement and its benefits. So we can share scientific papers. We have Wikipedia. We have all of these different ways of sharing cultural life and community. We can send cat pictures to our friends and family. And everyone's entitled to a social and international order that protects all of these things. So that's very nice. The thing is, human rights apply to all of us equally, except in the UK where they're trying to change that. And issues affect us globally. So I don't think we can say that what happens with the Trump administration in the US doesn't affect us here in Australia. Of course it does. Ask some New Zealanders if what happens in Australia affects them as they look at the plumes of smoke floating overhead at the moment. Of course, what happens around the world has an effect on us here. So we need to not just inform ourselves locally about what's going on, but we need to inform ourselves globally about what's going on so we can participate. We need to understand worldwide, and that's what the internet gives us. It gives us a global communication tool so that we can share and disseminate information. So there are certain requirements for a democracy to function. As I mentioned, we obviously need to inform ourselves. We need to vote. There are all sorts of things that we can do in a democracy beyond voting, however. We can join lobby groups, we can protest, we can do all sorts of different things. And the internet is a backing tool for all of that. It enables us to function globally in a democratic way. One of the things it lets us do is find out about news from around the world, locally and globally. That was not so easy before. You're reliant on local media, whereas now we can access global media. More than that, it enables journalists to communicate with their sources. And that's important. For journalists to be able to securely communicate with their sources, is a fundamental part of democracy, and the internet enables that. You can also go to the Parliament website and watch what's going on. You can look up bills that are going through. On that same site, you can fill in an e-petition. You can say what you want to happen or not to happen. In the UK, I don't know if there's an equivalent site in Australia. Perhaps somebody can tell me. I've been living overseas for most of the last 20 years. So in the UK, there's They Work For You, which means you can go onto that website, punch in your postcode, and it tells you who your local representatives are, what their voting record is, what their attendance record is. Did you just vote them in and they've never actually turned up? How often they've defied their party whip to actually express an opinion of their own. This is very useful. If this doesn't exist in Australia, perhaps if you want to do something for your democracy, go and create it. There is. Okay. Good. Okay. It's a really handy site. I use it quite a bit, especially when elections are coming up. Protesting is another way we can participate in our democracy. These are some photos from Wikipedia of the Arab Spring protests that happened around the world. Now, those protests were largely organised on Twitter and on the internet. That's how these people coordinated. And more than that, it's how they informed themselves that success in one country might lead to success in theirs. When they found that protests were going on and that a dictator was toppled in one country, another country kicked off and went, right, we're going to take to the streets too, we're going to do something. And that's how this series of protests in each country took off. So it also enables whistleblowers to publish information about what's going on. People like Edward Snowden, Chelsea Manning, can publish information telling us what our governments are up to. And not just governments, but if you work for, I don't know, say a large oil corporation who's chucking oil into the sea and you can't get something done about it within your company, then you can be a whistleblower in a corporate way as well. It's very important we have access to this information in order to function as a democracy. Without the internet, that's a lot more difficult. So, unfortunately, that democratic tool is under threat. It's under threat from criminals. Everything's always under threat from criminals. I'm not as worried about this. I'm more worried about the threat from corporations and from governments. It's quite scary that our own democracy is under threat from governments, but unfortunately that is the case. When this happens, a lot of governments aren't very keen on this. So when they see this, they do this. This is NetBlocks. They run a Twitter account. They run a website. Basically, they monitor internet connectivity in countries around the world. And if you follow them on Twitter, you'll see when different countries around the world lose their internet connectivity. Now, that may be because a fishing trawler has dug up an undersea cable. Have that with your chips. But it's also often because something has been going on in that country, and they report on that. They report upon the reasons why. So, we've got Iraq up there. We've got Iran having shut down large chunks of their internet. India and Yemen. It's also happened in a number of African countries. And Russia has, at points, deliberately cut off large chunks of their internet from the rest of the world. They've been practicing isolating the Russian internet from the rest of the world internet. So that's not great for our democratic tool. This sometimes happens. If you remember this was last year in June. The Australian Federal Police raided the ABC offices. That's not great in a democracy. They also raided the home of one of your journalists. Censorship. Governments around the world are very keen to restrict what we see and what we say. We might be very concerned to hear about the Great Firewall of China. Well, the Great Firewall of Australia is not a much better idea, really, either. Censorship in any form is a problem, and it gets in the way of our functioning democracy. Surveillance capitalism, these guys, not all of those guys, and particularly, no, we won't mention any that are sponsoring this conference, of course. They're fine. Yeah, billion-dollar corporations that scoop up your data and monetize it. That is a bit of a problem. We hear about leaks of data from time to time, and we think, oh, that's a concern. But the problem is that it's not accidental. When you hear there's been a large breach of data, it's not, I mean, that one individual instance might have been an accident. Somebody might have made a mistake. Oops, I forgot to encrypt the data. Oops, it leaked. But it's an inevitable consequence of the business models of these corporations. And you know, when Google first came out, I was a big fan. I thought, yes, you have a much better search engine than we'd had previously. Instead of being interrupt-driven, when you search for something, it presents some relevant advertising next to it. I loved it. I didn't mind that advertising. Where they started to cross the line is when they started personalizing results to you, trying to understand things about you as individuals, things you might not even know yourself or which your family don't know. And that's a bit of a problem. This is where the surveillance capitalism line has been crossed. Facebook, it's fine sharing your cat pictures with your friends, but that's not all they do. The Cambridge Analytica stuff, which I think was discussed in the last session, is one example of where that is a problem. Much of what they're doing is not for your benefit. So, surveillance capitalism, large corporations processing your data leads to this. This is, I think, Google's Berkeley data center. It leads to massive centralisation. Now, all of that processing going on there is not for you. You think, well, okay, Google, Facebook, and Amazon and so on, they all need data centers. They all need servers to serve your requests, to provide the service that you're using them for. But do you really think that all of that is serving you? Or is much of that, in fact, most of that, serving them, their profit generation, their collection, processing, sale of your data? It really doesn't take all of that to process your cat pictures. Much of what's going on in there is trying to understand who you are, what you like, who you associate with, and find ways of monetizing that. That's their business model. It's not accidental. These corporations don't occasionally do something bad. It's their business model. They can't change. We can bring in all the laws in the world. We can fine them billions of dollars. It's just a cost of doing business to them. And if we go back to that picture for a second, you see the big substation in the foreground there? What is a data center except for a lot of computers all in one spot generating heat? And that really doesn't please this guy. Or Greta Thunberg, for that matter. She's getting quite cross about it. So if we want to do something about that, we should perhaps stop giving all of our data to these surveillance capitalist organizations. So we have technologies like this. We have OpenVPN, we have Tor, Privacy Badger, PGP. These are all great, but they're all really band-aid solutions. They all exist because the internet that we have today is not fit for purpose. The internet that we have today does not provide security by default. The internet that we have today does not provide privacy by default. We use things like Tor to replace that lack. We need to do better than that. I would argue that the design goals of the internet have changed fundamentally. Essentially, when the original protocols were developed, security wasn't such a big deal. Privacy wasn't such a big issue. I mean, let's be honest, who's ever administered a server by Telnet? Come on, don't be shy. It's nothing to be embarrassed about. We didn't know better. We hadn't invented SSH then. We've got all these clear text protocols. I mean, still most of the email that we send and receive today is flowing in clear text. We're starting to get the idea. New protocols like WebRTC and so on have got encryption baked into them, sometimes in a problematic way, but we're starting to get there. We're starting to use HTTPS, although that's got its own issues. So if the design goals have changed, I mean, what are some of the design goals that we should be thinking about for a next generation internet? Shout some out at me.
Anonymous.
Pardon?
Anonymous.
Anonymous, yes. Privacy, yes. Security, yes. Anything else? Performance, absolutely. I would add to that efficiency. Sorry?
Resilient to governments.
Resilient to governments, absolutely. Data ownership, good.
Not enabling abuse specters against diverse members of the community.
Not enabling, yes, right.
Laws of mathematics.
Laws of mathematics. Yes, well, they don't apply. Do they apply in Australia? I'm not sure. See, look, I'm a bit worried in some ways. I don't have a lot of hope for you today, actually. I'm a bit worried it's all a bit late. I mean, I realise I'm probably talking mostly to my bubble here, that you guys realise the issues. So you're probably not the people I need to be talking to at all. Just chuck you all out and grab everyone, round up everyone who hasn't come to this talk. It's a problem. So what are we going to do? What can we do? Well, as technologists, we need to think about user rights by default. We need to think about protecting privacy by default. We need to think about not using login systems from certain cloud providers and so on, where you're forcing users of your site to share their data with, Google, Facebook, WordPress, someone else. Use your own. We need to think about encrypting data end-to-end and at rest. This needs to be considered from the outset. And we're not always doing that, but the people in this room have the power to do that. We understand these issues as technologists. Not every home user does. And they're not going to go and turn on some safety feature. It needs to be the default. I would say that we need to think about building a next generation internet. And that internet needs to be rights enabled by default. It needs to be secure by default and private by default. It needs to be decentralized. It needs to be end-to-end connected. And that means no more carrier-grade NAT. That means no more IPv4. That means having IPv6 at your conferences on the Gold Coast. Sorry. That means it needs to be scalable. And I would argue that the unicast internet that we have today is not, although it may appear to be. We need something that's more efficient as well, because of all of those data centers and all of those pissed off polar bears. So if that sounds great, how are we going to do it? I have some ideas about how we could rebuild the internet. So let's talk about multicast. I don't think you can build a decentralized, privacy, rights-enabled internet using unicast. I think we need to move on. Multicast exists. It's just not very widely used. Who's used multicast? Oh, good. Keep your hand up if you've used IPv6 multicast. Okay, we've got a couple. Excellent. Come to my talk on Friday. Multicast is scalable, far more scalable than unicast. It solves real-world problems. It's private by default. I'll explain more about that in a minute. It's the missing piece in the decentralization puzzle, I feel. It's far more efficient. You want to talk to 1 million nodes, you can do that by sending one packet. In the unicast, you send 1 million packets. It's not very smart. And therefore, it makes this fellow a lot happier. So what is multicast? You might have seen some sort of definition before. If you've casually glanced at a university textbook or something, you might have seen unicast. Unicast's one-to-one, right? We've all heard that. And then you've got broadcast. We tend not to use that too much on the internet, but that's one to all nodes. And of course, it doesn't exist in IPv6. We've replaced that with multicast, which is one to many, yeah? All agree with that? Because that's wrong. No form of IP multicast in use today is one to many. It's one to a group. In the case of unicast, the sender sets the destination. In the case of multicast, you don't set multiple destinations. You send to a group. You have absolutely no idea, as the sender, whether any nodes are listening at all. Hence, we have privacy. In the case of a multicast packet, well, in the case of a unicast packet, we have a source and destination address on every packet. That's not a great starting point for privacy and security, is it? We can do better than that. In the case of multicast, there is no destination IP address. You send to a group, and it's pub/sub. If nobody's subscribed to that group, then they don't receive the data. You can't spam someone over multicast. If they haven't signed up to your group, they don't get anything. Unicast, the sender is in control. The sender needs to know and manage all of the addresses of all of the recipients. So, for example, if I'm an MX server and I receive some email and it's destined for multiple recipients, I need to go and look up the MX records of all of the recipients. I've got to manage all of that. And that all happens at the application layer. The more clients that I've got, the higher my load. I argue it's therefore not scalable. It's inefficient. Multicast, on the other hand, the receiver is in control. You decide if you want to join a group and which groups. The sender has no idea you're even there. In a multicast world, I'd be giving this talk and I simply wouldn't know if there was anyone in the room. In a unicast world to give this talk, I'd need to individually give the talk to each of you. That would take quite a long time. Doing it in a multicast world, I just give the talk and I have no idea whether you're even out there. There could be more people coming into the room as I'm giving the talk, and the load on me as the speaker doesn't change. And this all happens at the network layer, not at the application layer. The load's constant, as I say, regardless. It's therefore a lot more scalable, and it keeps our polar bears happy. Now, there's quite a movement in the world at the moment to decentralize the internet. There's all sorts of projects out there. There's Mastodon and Matrix and so on and so forth. But the trouble is, they all work up here at this application layer. Multicast lets us do this down here. That's rather more efficient, I think. So shall we have a look at a real-world example of how multicast can help? If you've got a bunch of IoT devices, mobile phones, fridges, washing machines, whatever, and they all need an update, in a unicast world, if you've got 1 million of them, you've got to send that out 1 million times. Now, all of those devices would need to connect in, and you're going to have proxies and CDNs and all sorts in order to cope with the load. We can do something a little bit clever in the multicast world using single source multicast. I've built a little IoT updater. Now, there's a bit more to it. This is sort of the main part of it, but I mean, it's 90 source lines of code is the total server, just to give you an idea. It's quite noddy and simple. It's just a demo. But I mean, up here, it's using the LibreCast libraries to... This is going to look very familiar to anyone who's used ZeroMQ. That's deliberate. I was designing the API, and I realized it was confusingly similar to ZeroMQ, so I made it more similar. So basically, you create a new context, create a socket, create a channel, bind the channel to the socket. You bind as many as you like. And then off we go. And then here we've got our main event loop, which is just sending the data. Now, all this has done, it's really noddy, it's really simple. It's memory mapped to file, and it's just sending it on a loop constantly. Now, the thing about multicast is you can do that, because if nobody's listening, no data is sent. In the worst case, it gets dropped by the first hop router or by your switch using MLD snooping or IGMP snooping if you're stuck in an IPv4 world. And with single source multicast, there are tricks where we can avoid even getting that far. We just stop sending. We won't know how many people are listening. We'll just know that there's at least one. So I would say it's a naughty little demo, but basically it's just sending that file on a loop constantly. And so the client just creates a memory map and starts receiving data. So it's got a datagram that comes in that's got a checksum of the total file. It's got the size of the total file. It's got the size of the chunk of data that's being sent. It's got the offset where that bit of data belongs in the file and the data itself. It's a very simple datagram, a couple of integers and some data. So if we were to receive a file, again, we've got our empty memory map, our sparse file here, and we receive a chunk of data. And that's got an offset of 0 and a length of 4, so it plonks in there. And then we get another one that's got an offset of 4, and so we plonk it in after that. But the thing is, this is UDP, this is multicast. So these chunks of data could arrive in any order, they might not arrive at all. We don't care. We'll just plonk them in any old where. We've got our offset, we know where it goes, so we don't really care what order the packets arrive in. We just start receiving our data, and off it goes. Boom, boom. Oh, I think we've got enough data. Yep, we've got as much data as we need. Let's run our checksum, that matches. Hey, we've got our file. Now we can do that with 1 million nodes, 1 billion nodes, doesn't matter. You run this off a tiny virtual machine. You don't need any caching, you don't need any CDNs. It's pretty much infinitely scalable. Why aren't we doing this? All this requires to work is one setting to be turned on a router. IPv6 multicast is supported on basically every Cisco and Juniper made in about the last 15 years, but it's off by default. In order for IPv6 multicast to work, at least with single source multicast, you need to turn on one setting. IPv6 multicast routing on. There we go. And this works. Now, unfortunately, that means turning that on every router on the internet. That's where my project comes in. We need to get there. We need to convince people that turning that on or having that on by default is the way to go. Because I hope I'm demonstrating here that multicast is kind of useful. It'd be good if we had it on by default. I'm not the only one who thinks that. That's Cory Doctorow, turning up for an awards ceremony, dressed as his XKCD character. He did a podcast a couple of months ago that I listened to. And he talked about the idea of sending data sort of in a broadcast way so that you could protect the privacy of the people receiving it. That you basically, you wouldn't know who was receiving what because you're just sending it all the time. And he said, well, we've got technologies like IP broadcast, we could do this. Well, obviously that wouldn't work exactly on the internet. We can't broadcast to the whole internet. You know, we can do that with a radio station, but we could multicast it. You could have something like that little IoT updater. You could run an entire web server like that. If you can imagine every static web server just sending all of its files all of the time, you can be updating as many nodes as you like. Basically, your client, your HTTP browser would simply join a multicast channel for each file that it needs to receive. It would join a file for the index, and that would tell it which other channels to join. The server has no idea that that client is even there. The load is totally unchanged, and it just pulls down all of the data, exactly like we did there. The scaling factor, well, obviously it's pretty much infinitely scalable. The only thing you need to cope with is the number of files that you're serving. Can you serve all of the files that you have? And obviously we've got to do that already with a unicast web server. So multicast can pretty much do everything that unicast can do. It can do some of those things better. A few of those things it can do only as well as unicast. but we can basically do everything over multicast. So that brings us to my project, LibreCast, which aims to bring multicast to the internet. Who's heard of the M-bone? Yeah? Cool. What happened to that? Yeah, unfortunately, but we did have multicast on the internet. Rod Stewart did a concert over the M-bone, famously back in the 90s, I think. But yeah, towards the end of the 90s, it just kind of faded away. But essentially, the M-bone was a multicast network. It was IPv4 only, of course, back then. But if you wanted to do some multicast and you wanted to talk to some other people who were doing multicast, then you just tunneled to a backbone and you all joined up and had a contiguous multicast network. Wonderful. It was mainly based around streaming video and audio and such. And that's mostly, unfortunately, what people think of when they think of multicast. They think about audio and video streaming. Now, my argument is multicast is for far more than that. Multicast is about group communication. That's really its party trick. Yes, it can stream video, and it can do that far better than unicast can. There was a tweet by LANAP in the UK, a London exchange, saying how much their traffic had spiked because everyone was watching the football. That's lots of people watching the football, watching the same stream at the same time, and they're getting a peak in load. We don't need to do that with multicast. Just send one copy, they all get it, it's the same data at the same time. And as we've seen, there are cases where we can do this, where we're not sending it necessarily at the same time. We can run a whole web server over that. So LibreCast aims to basically get multicast in the hands of developers. We already have technologies for hooking together disparate bits of multicast. We can use technologies like AMT, automatic multicast tunneling. It's a fairly recent RFC, last 2-3 years, but essentially you run that on your Cisco or Juniper router, you connect your ASN, your autonomous network, to somebody else's who wants to do multicast, and you can connect through an area that doesn't support multicast. It's just tunnels, just like M-bone, just like Castgate, if you'd heard of that, probably not. Vrije Universiteit in Brussels did a similar sort of tunneling thing with a browser plugin. But you don't really have access to your local router, and you certainly don't have access to every router your software users are going to be accessing the internet over. So my aim is to get multicast into the hands of developers. So you just hash include librecast.h and off you go. So essentially it's, at the moment, just a plain multicast library. The next phase, the next part of the roadmap is to turn that into more of a messaging library, a bit like 0MQ. To build transitional tunneling on top of that. I mean, I'm not inventing anything here, folks. This all exists. We've done this before. The M-bone did this. So what I'm trying to do is bring you 1990s technology, but in a usable form. And to build an improved routing protocol, multicast doesn't have a destination address. I would argue it doesn't necessarily need a source address either. There are routing protocols that don't. We do things the way we do because we were thinking about unicast. When we realize the power of multicast, we can try and do things a little bit more efficiently. And what I want to do is work with foss projects to enable multicast everywhere it can be. So once we have the transitional stuff fully working, which should be about mid this year, then there are lots of cases where multicast can work. There are already many. If you are running within your own data center, within your own network that you control, well, you can use multicast today. Nobody's stopping you. I built a little chat server as a demo. You connect in over HTTPS, over unicast. And for the messaging in the background, it's all using multicast. It's multicast on localhost. It never actually leaves the local machine. But I'm using the network layer inside the kernel to handle the message passing, to keep track of which users are interested in which channels. So it's basically IRC essentially, but multicast. And if you plug more than one of these nodes, more than one of these servers into a multicast connected network, then what you end up with is federation, essentially, automatically, with 0 lines of code. When I realized that, I thought that was pretty cool, and I made myself a strong cup of tea. So we also need to ensure that new standards support multicast. I mentioned WebRTC earlier. WebRTC is good in that it has encryption built in, but we've historically tended to separate out transport from encryption and that sort of thing. It's good to have that separation. I understand the reasons why they baked in the encryption, but the thing about WebRTC is it's UDP, so it could have worked with multicast. But because of the particular one-to-one key exchange that goes on with WebRTC, it doesn't yet work with multicast. I'd like to do something about that. QUIC, which forms the basis of QUIC, which forms the basis of HTTP 3, is UDP. See, for a long time, I thought the real barrier to adoption of multicast was going to be the fact it's UDP and everyone has a TCP addiction. But then this happened. We're going to be having the web over UDP. So that means we could have the web over multicast. And I'm not the only one who thought this. The BBC research team in the UK are working on an RFC to do exactly that. Now that's so they can put their iPlayer streaming stuff out there because everyone thinks multicast is just for streaming. But I plan to have a little word to them about other applications for that. So there's an opportunity for you guys here. If you're a security researcher, you're just interested in these technologies, multicast really hasn't got a lot of people working on it. So you can be at the bleeding edge very quickly, as I discovered. There's very little in the way of security tools, for example. There's very little in the way of research that's been done into multicast security, and it needs to happen. That means there's an opportunity for you to contribute to what should be the next generation of the internet. So if that interests you, come and talk to me afterwards. I have another talk on Friday where I'll be going into a lot more detail on the technical side of multicast and so on. So if this interests you, do come along to that. My contact details are up there, and I'm here all week. So I love talking about multicast. Come and talk to me. Ask any questions. If you want to know about NGI 0 and getting funding for your internet-related project, then come and talk to me about that. So I think we still have some time for questions.
Thank you very much, Brett. We do have 5 minutes until the lunch break. So we'll take some questions until then, but I'm sure Brett's going to be around and happy to take that into the break as well.
Absolutely.
Yeah. So I've got a question here.
Hi. A little question. So when we discuss about decentralization, we discuss about maybe taking out some of the bad players, people that abused our trust, for example, governments, banks, etc. So how do we balance when we go to decentralization safety? So for example, we remove also the good players, possibly good governments that should protect us, or banks that should protect our money, etc. So how do we make decentralization also safe?
Okay. Well, essentially, with centralized systems, you have a lot of control, and there are certainly cases where you want a centralized system, perhaps for a corporation or so on, that wants particular control over that application. You can still build a centralized system with multicast, but it's not that way by default. If you want authentication, you need to bake that into your application. And what I'm trying to do with LibreCast is build a toolkit. I'm not trying to do all of the work for you. There is no one-size-fits solution for a one-size-fits-all solution for security. What I'm trying to build is a bit of a toolkit so that you can put authentication in there, put logging in there, and so on. And all these things are available in a multicast world. They're just not there by default necessarily. I mean, they're not really there by default in unicast, but you certainly have a lot more control and visibility in unicast by default. By default, multicast is wide open. You can use pretty much all of the security protocols that you can use in unicast. There are difficulties with things like, say, perfect forward secrecy or forward secrecy. If you want to implement that in a multicast way, well, you can in the same way that you can in a unicast way, but then you've just lost your amazing scalability because now you've got to do this Diffie-Hellman key exchange, and that's putting you back to one-to-one. And that's why I say there's this amazing opportunity here for research, because there hasn't been enough research into properly decentralized security. So yeah, come and talk to me about that.
So thanks for that. This is a very interesting topic in terms of decentralization, and you say it's an opportunity. There's a paper from 1981 published by MIT called End-to-End Systems Design, and it discusses how basically, you have to assume that every network in between two endpoints is always hostile, and you've indicated that you require routers to be multicast enabled to enable this technology. How would you, in this scenario, prevent, say, a government that just turns off multicast on their routers as a threat model, assuming that the entire network is hostile to the multicast layers above?
Well, a government could today just turn off the internet. We've seen that they do that. There are economic arguments and democratic arguments for keeping the internet switched on and working. I think part of what is going to help multicast succeed is, frankly, money. There's a lot of incentive for large corporations, these surveillance capitalists, to keep everything centralized and controlled, but they also care about their bottom line. If you can build 1/10 as many data centers, that saves you billions of dollars. If you are Netflix, which I think accounts for, what percentage is it of internet traffic? Something huge. There's like 25% or something of global internet traffic is Netflix and equivalent, and it's rising. Then the efficiency that you get from using multicast saves you literally billions. I think that's the argument for keeping this switched on. And increasingly, I think countries are going to become more and more dependent on the internet. I mean, we're pretty dependent on it now. Tin pot countries that turn it off are the exception rather than the rule. So yeah, it's a problem, and we can tunnel through problem areas, but ultimately to have multicast everywhere, I mean, the real power of that is we don't know who's talking to who about what. Your metadata is hidden by default. So if you want to shut down traffic in a multicast world, you really are pretty much shutting down everything because you just don't know what you've turned off. So I think, yeah, there are definitely problems to overcome, but I think multicast has a number of things on its side. And I said before earlier that I'm not terribly hopeful in some ways. I think maybe in some ways it's a bit late. I don't think enough people care about privacy and so on, but we do have a couple of things on our side. Whatever Malcolm Turnbull might like to say about the matter, we have got the laws of mathematics on our side. We have got some pretty awesome weapons. And we have got human rights on our side. And I think those two things might be the key to winning this battle.
Yeah.
Sure.
So how do you handle things like retransmitting dropped packets in this model?
Complicated topic. I will be covering it on Friday. Come to my talk on Friday. In the case of things like the IoT updater, obviously it's on a loop and repeat, so it doesn't care. Get it on the next one. There are some funky tricks that we can do with multicast that you simply can't do in unicast. You can send multiple streams of the same thing offset. So if you miss one, quickly join the other channel and grab it. And again, if nobody's listening, no data's sent, so it's not a problem. In the case of audio, for example, we have quite a few interesting tricks we can do with that. I'm working on a sort of video streaming decentralized project at the moment. It's part of what NLNet are funding. And what we're planning to do with that is send different quality streams on different channels at the same time. So where unicast has to, in your media server, you have to choose what quality stream you're going to send to which recipient. In the multicast world, that happens automatically, and it's in the receiver's control. They simply join all 3 channels, for example. You might have a low, a medium, and a high quality channel. They join all 3. Somebody who's on a bandwidth restricted network and wants to run in a low quality just joins the low quality stream. And essentially what that's doing, with audio and video, we can just simply drop packets. That's essentially how it works. I mean, there's no point with an audio stream receiving a packet late. You don't want a retransmission in the middle of your audio stream. There's no point, if you missed something I said earlier, there's no point in me sort of dropping those couple of words in the middle of my sentence now. It doesn't work. But yeah, I'll go into more detail. There's quite a few things to do with that. Flow control is another issue that I've not covered. There's a lot of interesting things. Multicast has a lot of surprising properties. So it needs more attention, I think.
All right, folks, please join me in thanking Brett. Thank you for your time.